Hello, everybody. Thank you very much for joining us. Is it possible to kill these slides a little bit because I can't see anything? Okay. Okay. Anyway, so the most important question is why? No. You killed someone else now. No, actually, keep it. It will be easier for me. So, one of the most important question is why do we need security from a business perspective? Is managing the residual risk. So, if you think about if you're a founder of a startup or CEO of a company, you wouldn't be care about how identify vulnerabilities or how would you fix them. The most important answer you are looking for, are there any risk or not, and how do we manage risk? To do this, we need to understand common vulnerabilities. Because if you look at the industry, this is not a data, but it's my gut feeling. Most of the vulnerabilities is coming from common mistakes. So this is the initial steps of a framework. It's very similar to OWASP Top 10 and also other initiatives like SANS Top 25. It's coming from last 4 years of, mostly 4 years of know-how of Parity's engagement with third-party auditors and also internal audit process. So we realized that it's very important that if we can create a category for each vulnerabilities, it will be easy to manage and educate developers. Because at the end, the most important part is developer will use this or not. Because otherwise, it's not going to work. So Giovanny will be looking after 4 example vulnerabilities today. We are not going to do all of them because it's a framework, you can use it, and it will take time to do it one by one. But eventually, we will introduce a little bit surprise and a little bit gift for the community for using something to educate your developers. So please welcome Giovanny.
Hello. Hello, everyone. I'm application security engineer. I work with Serhan, and we pretty much all the time are looking at these kind of issues, not only internally, but it's a discussion that we have with parachutes that contact us about things that they found initially in development. Some has, as Serhan has mentioned, this is we are not going through each one of them because it will take us too much time, and we actually try to go in deep into the examples. But what we are trying to do is trying to show you exactly, at least some of the 4 that we are going to be talking, what are the key takeaways that we have, a few recommendations in terms of mitigation, and you can actually see at the end some of the links about the resources and how you can learn more or go more in deep. For the first one, it's not changing. Okay, it's not. Okay. So the first one is insecure randomness. It's from the category that we name cryptography failures. In this one is when you start to use a library. In this library, you are using it for encryption or whatever thing that you want to rely cryptography on, but the algorithm that you are using is not strong enough for the operations or for the use case that you are actually looking to work on, or what are the requirements that you have for the algorithm. So this is something that we have seen in the past. There are a lot of kind of algorithms that you can choose from, but it doesn't mean that all of them are optimized for specific questions and specific situations. And most of the time, people rely on what is popular on or hot at the moment, or some of them are more conservative, of course, but you have downsides on both sides. On going more conservative, you are probably missing on the new features that algorithm has to protect you from new things that have appeared over the years. Or if you are more into the new stuff, you probably don't need the new stuff, and you are doing some more basic cryptography operations that are probably more efficient in the old way. So yeah, of course, the risk is manipulation of the prediction in terms of functionality and leading to putting yourself into compromised state. Mitigation, in our experiences, developers, and I think this is something that we discussed in the previous talk with Karsten from SRL Labs, is he's here in the front. It's more that if you're working in the blockchain market or if you're working in the crypto or blockchain market, you as a developer or as an engineer, you should be aware that you need to know about security as a baseline. If you are not prepared to take security on the day-to-day job, like, you probably are working in the wrong industry. Why? Because you can see it all the time, everywhere, the kind of hacks and the exposure and the assets that are lost every day or every week or every month, however you want to see it. Of course, it depends on the ecosystem, that is it's more frequent or not. But not because you are a small project, not because you are having low amount of assets or risk, it doesn't mean that it's not going to happen to you. Eventually it will happen in next, one day is a major blockchain, the other day is a small blockchain, then it disappears from one day to another. In this scenario where it's a case, it's an example that we have, and it's an secure approach in the randoms collective flip palette from Substrate, and provides a random function that generates a low influence random values based on a block hashes. This is pretty much how the code works. We have other presentations or other material that you will have access when it describes a little bit more the example. I cannot go through it because the time is running really quickly. So this one will be the unsafe approach on how to do it. And the safe approach is how you can actually rely on more common, well-known methods. And something that I think in the talk for backup yesterday about the Polkadot Ethereum bridge, he was mentioning some of the usage that you can use with random for the light clients, right? But the thing is, of course, if you saw, or I invite you to give it a check to the Ethereum bridge talk from backup. There's some, even with the random, there are biases that can be introduced into the algorithm. So even if you are recommending it, depending on the scenario, it can be backfire, and you can actually, like, do not take this like as I'm going to use it just because it's recommended, and it doesn't matter the use case. You actually have to evaluate if it's actually worth it, or is not going to introduce, if you don't need to do anything else, or you can need to put some thought on it. And again, Polkadot uses BRFF for the majority of it. So takeaways, chain randomness is difficult to get around and to understand it, and especially get a grasp about all the possible states and scenarios when these can be exploited. And for the mitigation measures, of course, random use case, all values can be trusted. And then you can probably think in some scenarios where the randomness, you can put a scenario where it costs too much to broke the randomness and make probably monetary incentives for that to not happen. Now we have another risk. There is storage execution and security misconfiguration. This usually happens for parachains or teams or projects in general, that when they are starting something and they are not really sure about what to put in the initial configuration, there's people probably might not be aware about putting 0 or really low values for transaction costs. And someone can actually check exactly what are the values that you're setting, and they can just utilize that. If it's too cheap to occupy a storage, someone is going to create a bot or whatever it's going to, and it's going to send really cheap transactions that it will occupy storage. And at the end, it's your fault for not thinking about the economics of your transactions. And usually, again, this happens when people are just copying what they see online or in a GitHub repository, and they just really don't think why, in first place, was this the configuration. Yes, so this one is an example about the existential deposit. I mean, if you have an account or you have an address, you know that at some point there's a minimal existential deposit, at least in Polkadot, is 1 dot. And when you have this really low, of course, it's the same. You are giving attackers or random people to either that commit an error, or they are intentionally occupying the storage from your chain with the target of damaging the stability, and is going to affect others, or the people that is using in the the chain. This is something that it was actually happening in the NFT v2 implementation. This is a case that you can actually give it a check, and you can see the story about what happened, and this is what's covered in an internal audit. So you can actually give it a check and see the piece of code. Main takeaways, always explicitly require an existential deposit, and make sure that those numbers make sense. Of course, you don't want existential deposits to be impossible. I mean, if your project is really small, it's not too popular, maybe having an existential deposit that it's equal to a really high amount of value, then it doesn't make too much sense. But then do the math, do some tests to actually make sure that whatever you're putting in the configuration makes sense. Mitigation, of course, if you are doing transactions, like make sure don't think that the palette that you're using has all the logic to check for deposits or balances that are available to finish a string or finish a transaction. You always need to check that. Sometimes if you don't do it correctly, or if you assume that the palette has the logic for it, what can happen is that you can have an account that can be locked. You can put a lock in your account. Or users can put a locks in their accounts because you are not actually doing. Of course, we have this one that is unsafe arithmetic. I think this is something that at least is a little bit more common in terms of not only for blockchain, but security, and I think for all auditors, they're really familiar with this, and it's part of the security design, and it's how you can actually be doing mathematical operations that are not safe, and in terms of not making sure that if there are certain transactions that you are doing and they require these mathematical calculations that can lead to disadvantages. For example, what about if you are trying to have this calculation or about, for example, voting power based on the balances that you have in your address, and if you don't do correct arithmetic operations, you might be giving away some advantage to addresses or malicious actors to get more power, or depending on the case. Or maybe you could be running into a situation when you have a division by 0 and you are getting into a panic or a crash or something like that. The mitigation is, this is something that is more common in the Rust ecosystem. It's about using check or saturated functions. This is not new to blockchain. It's more on the safe way of programming language. This is an example on unsafe. The main change is just on the way that you are using the check operations instead of going raw on the calculations, like the arithmetic function. The main takeaways: while testing palettes, system will crash, of course, but then depending on in production, it might not crash because it gets taken away by the Rust compiler when you are actually generating the production binary. And again, finally, is for this one is, I mean, use check and saturated functions. Usually those there are packaged for that, but not all of the functions have a check equivalent. Even if you check, for example, in the SP arithmetic crate, most of the functions that are available in frame in the primitives section of the Polkadot SDK and frame, they have check functions, but it's not always the case, and you have to implement those. And actually, if you check that package, you will see that there's one way to make sure that it's safe enough or secure enough. There are some fuzzing tests that are being applied to make sure that everything stays normal. And this one is a little bit more related to the previous one, but instead of being unsafe mathematical operations, you are doing unsafe comparison. And this is, again, in security design. Why? Because it's more in how the language or the casting works. I mean, this is pretty much like computer science topic. Is if you have a large number that takes a lot of, a type that takes bigger space, and you are done casting, maybe the language will not fail, but it will cut probably to the upper limit of that type to fit the number. And of course, imagine if you are doing that with balance. If you're doing it with balance, then the user is going to have less amount of total of assets or whatever you are trying to downcast. Usually, this is something that we check is like in terms of mitigation, try to apply checks, like make sure that whatever you are downcasting it will fit completely, and try to make sure that the result actually represents the initial value. However, you should not be architecturing for downcasting. Ideally, there should not be a case for that, but if it's the case, make sure that you are safe to go. So for this one, again, this is something in Frontier, if I recall correctly. Yes, no, it's not in Frontier. It's converting balance from the EVM side into Substrate, because there was some difference in the amount of that is coming from one side in the type to the other, and you were there was this bug of misrepresenting exactly the values that were coming from one side to another one. You can actually give it a check to the CVA to get more information for sure. And finally, for this one, the mitigations are a little bit more similar to the previous case. Is try to use unique saturated or into instead of low and other low type functions. Again, it depends on what you're using. There are crates that provide those functions, but if not, you need to create those and provide it to developers, because if not, they are going to use whatever is out of the box. And again, your system should not be designed to, it should be designed to avoid downcasting. I would like to know what is the reason why you would like to downcast, and maybe it's something that you can talk with the engineers and say, okay, maybe we are doing something that we shouldn't be doing in the first place. Serhan. So Serhan is going to come with the conclusions, and he's
Thank
going
you.
to.
So before going through the conclusion, I would like to thank especially 3 key stakeholders for this project. So the first one, of course, Parity engineering team for working with us and helping to mitigate security risks. And the second one is, of course, the Parity security team making that happen. And also the last one is SR Labs, of course, one of the oldest maybe partner of Parity, working with identifying those vulnerabilities, categorizing them, and making it public altogether. So you got the idea. This is a framework, and it was a grasp look of how it's structured. You can use it. There are some questions, for example, maybe think about it, not answer right now. For example, how we can improve this, and also how we can automate and more autonomous to stop common vulnerabilities. Because in a software development area, if you know some information, maybe you can automate with something, maybe a tool. And then when we look at blockchain technologies, we need to maybe accept that blockchain is a part of computer science, and security best practices coming from other industries are mostly still relevant for our technologies as well. So we cannot just ignore most of the security industry best practices, but what we can do, we can tweak them, we can implement them. So this is the one of the example, right? So we have for Ethereum as well. Also, you can look at the so-called Web 2 technologies, mobile application, OWASP top 10 mobile applications. It's the same idea. And also, maybe one important topic about audit. So getting audit, that doesn't mean it is secure, it is safe, it's not an insurance. So you can still get hacked, you can still identify vulnerabilities, because audit is just a snapshot of one moment and one commit. And also audit doesn't mean, unfortunately, there's a misunderstanding. I'm not going to go through details, but if you look at traditional security, traditional cybersecurity or software security, audit means something different. But in blockchain industry, unfortunately, we use audit as secure code review, and which is different than pen test, which is different than secure code review, but it works somehow. So the idea is that if you look at it, all the common vulnerabilities, that doesn't mean that they are common, is that all? No, probably maybe 100 more we can identify and we can put on it. So the idea is that being proactive, practical, look at them, reduce residual risk, and just have a good night's sleep. So if you would like to have more information, you can just go through Polkadot forum. And also you can go through Polkadot Blockchain Academy book. There's a section about applied security. And lastly, there is a video on YouTube, 1 hour and 30 minutes, which is explained in Polkadot Blockchain Academy in more detail, how it works and how it goes. So about the little surprise, I'm not going to be naked on the stage, so don't worry about it, but it's a game. So, you know, all ecosystems loves game, and it doesn't make sense not only reading a book or reading a vulnerability, that doesn't mean you can understand. So thanks to Parity security team, there is now a GitHub repository that you can go through, which is a Parity, a Substrate war game. So it has 2 stages. What you can do, if you want, you can act like a hacker. As a red team, you can attack the parachain and you can exploit vulnerabilities. Or you can act like a blue team, which is a developer trying to fix vulnerabilities. So two of them is important. And also, if you look at, there are some paddles like Raffle, Poker, and others. So thank you very much. I think it's important to maybe answer some of the questions or discuss thoughts. So let's start.
There's a lot of questions.
Hi, thanks for your talk. It's very interesting. I saw there was also a forum post, I think, by you guys probably about this vulnerability. Is very, very insightful. Yeah. So my question is, for some of these vulnerabilities, for instance, you know, integer overflows and division by 0, there are some tools like Clippy that already identifies this. You can configure it. Yes. There are other Rust static analysis tools which also could cover some of the others, but of course there's a lot of domain knowledge in many of data vulnerabilities. So have you guys looked into either provided some kind of tools for static code analysis, or plug in for existing tools which can help basically that we can put it in a CI pipeline and say, okay, this is wrong, fix it before you put it to production?
Yes, I mean, I cannot, unfortunately, I cannot tell you. I mean, the tools that that can do that right now. I do believe that there's a value on exploring, extending the Clippy rules that it checks for. Why? I mean, at least for now, because it's more. It has been at least a common trend of having Clippy enabled, and it's out of the box and it's pretty much integrated. So you will have like a pretty much output on that. Like right away, right? It will be running on the background, especially depending on the editor and whatever. But that's on the developer side, right? Now, to be able to check on that, I'm not aware. There's a few things that we would like to do, especially to translate this into more actionable and more dynamic ways of finding this, because of course this is knowledge, right? Does everybody has the time to check for this every time or every time that something is introduced? Ideally, you should know what you are doing, right? But exceptions can happen. So as far as I know, there's no today something that is translating those risks. There's a few of them that can be checked, but at least from what I can see, and I can see on the Polkadot SDK repo, they try to have this. At least for the check versions, you implement those and you accompany those tests or this implementation with fuzzing to be able to, at least for the arithmetic operations. Now, does it cover for the rest? No.
Is that a plan to?
Sorry?
Is that a plan to do something about?
I can explain that part.
Yes.
So of course there are some
directly.
there are some plans, but to talk about something, it needs to be a little bit more mature. So there are some things right now in mature that we cannot talk right now because of the details. So if you are not able to answer questions, you shouldn't talk about it. So but there are some plans to improve security. As that's why I asked the question, how we can automate those, because we know the knowledge. So the next step would be maybe the more autonomous.
And I think what we are looking for is having these conversations even on the forum. Like we we publish it, but we would like to know if people are interested in that, like where they want to see this, like, or what are the plans for this, because it seems that there's a lot of people who have read it, and they might have ideas or not, or how useful it is, but we don't know. We don't know what people really wanted from this. Like, do they find this useful or not? And at least what we are trying to use the forum as a way for feedback, or something that we will, if we want to spend time of this. Like now, it seems that it's a good idea to spend time of this. But for us, we are using other channels to be able to get this kind of feedback, and us to know exactly what the community thinks is important.
Great presentation, guys. I thought that was awesome. Yeah, I would second that. I think, Foundry is amazing in Ethereum ecosystem, and it's huge uptake. So I think some kind of testing suite would be great. My question is about the data. So did you get this data? Because Seal is actually working on a very similar thing, which is frameworks kind of for developers. And my question was around where you got the data from. Was it from exploits that happened? Was it from audits? Was it from internal Parity team, just checking logs? How did you come to that? Because I think the prioritization of that is so important, because essentially we're going to do 80-20 it, right? In terms of bugs and all this kind of thing. And so I'm just wondering if you could talk a little bit about how you arrived at those conclusions.
Yeah, the source of the knowledge is coming from mostly a combination of third-party audits, plus also internal audits, and also experience from the engagement with other parachains and their audit results as well. So it is not only coming from Parity, it's coming from a collective approach from the system. And also, I can give you an example. If you had a chance to join, there was a talk from Alp Onaran today, and the example of how they use, as an auditor, those knowledge and how to leverage. It's very important that, because those are the things already published on forum, and then people see them, engage them, understand them, and already start using them. And also, there were 11 security-related talks in Sub0, that means it's already started to get in an engagement. But of course, that doesn't mean it will stay as it is. It's not a law. It needs to be improving.
Yeah, and I mean, going a little bit more. Again, I think I'm using Barca for everything today. But with the topic of the bridges and Vincent, of course, the more that bridges becomes a topic in the ecosystem, then we will have more people try to build bridges, and we will have common security risk with bridges eventually. So this is something that will be evolving, and it evolves with the ecosystem. This is what we have today, risks for parachains. We will see what are the common risks for bridges. Maybe it's the consensus algorithm. Maybe it's the light clients. I don't know. I mean, we will see in the future. It depends. At the end, we are trying to take experience and materialize it.
Do we have still time to have one more question?
Yeah.
Okay, wonderful. One more. Yes, please.
Wait for because we don't hear.
Thank you. Well, great presentation. Thank you. Well, I know we already know each other, but I think for the record, how can we contribute to this framework?
Okay, that's wonderful. First of all, you will see, let me quickly go through here. If you look at there is a forum post on Polkadot, which named Common Vulnerabilities in Substrate Polkadot Development. And also we can just share the link in the Telegram chat as well. You can just look at it and contribute via forum post. But recent future, we expect to share GitHub repository, and also you can create issues and you can try to do some changes and improvements, so you can use it. So the overall idea, the question is for the next step for everybody. There's a know-how coming from maybe the last 4 years, so how we can leverage all together to mitigate risk. So it's going to be the question we will answer all together. So thank you very much.
Thank you.
Thank you, gentlemen.